I don't think it's a successful presentation unless people are actually laughing. So even if I'm not funny, laugh anyway. There we go, exactly. Thank you. Awesome, okay. So what we're gonna be talking about today is hacking the cloud, right? So the cloud and virtualization has changed penetration testing, even forensics and incident response in a major way. Okay, so it's still all the same kind of tools, it's all the same kind of methodology, but the technology, the stack itself has really changed stuff. How cloud and virtualization have changed penetration testing, a diary from the Garden of Red versus Blue. So we're gonna talk about red teams and blue teams. We're gonna talk about cloud. There were some people that walked up to me and during lunch said, okay, what the hell is an elastic beanstalk? Okay, fat-free, cholesterol-free. So we're gonna talk about elastic beanstalks and green beans and all kinds of good stuff and hacking them. Did you know that as an incident response organization, over the last, let's say, year or so, more than 80% of our incident response investigations have actually been the compromise of cloud servers. Okay, so more and more incident response calls are involving cloud servers. So we're going to talk about cloud servers and what that means, and we're going to talk about how you actually go about penetration testing and red teaming these technologies. I've done about 100 penetration tests since 2001, about 50 product pen tests. So we actually just won a contract to pen test all of the new smart cars coming out, right? So when you guys are driving around in those cars, they're actually putting Wi-Fi wireless access points in there. And the manufacturers are actually going to be able to push patches to your car from the cloud, right? Whoa. The cloud, no one understands the cloud. No, sorry, reference from a movie. I'm going to quote movies a lot today, so just kind of keep up with me. I used to work for the US intelligence community. I know it's really weird to think about. I was very much a black sheep in the intelligence community, but we did a lot of cyber operations, human stuff. I do run the Garden blog, Diary from the Garden of Good and Evil over at Alien Vault, so check it out. Let's see, so forensic analyst. Over the last couple years, I led a lot of the APT incident response investigations involving the Chinese and North Koreans stealing intellectual property, specifically in the area of biotechnology and pharmaceuticals, life sciences. So been doing a lot of APT stuff. And believe it or not, a lot of it is in the cloud. Let's see, so serial entrepreneur, I started and sold 2 previous companies before this. I started my first company when I was 17. Just recently, and I sold both to public companies. Breyer and Thorne, which is the firm that I run now, is a risk management consultancy. So we're hired by companies to hack into them, for lack of a better word. So let's see, what else do we do? Incident response and forensics. We also do ISO 27001 and SOC 2. I'm also a certified BSI ISO 27001 lead auditor.
It went up to the cloud.
You can't get it down from the cloud?
Nobody understands the cloud. It's a mystery.
It's a mystery, right? Okay, let's talk about the cloud. So the cloud is not a passing fad, right? The cloud is not a passing fad. It's here to stay. It's really easy to refute future statistics and future things, but the history is really hard to refute. So these are some great quotes. I'll just read a couple. 60% of businesses across 18 countries surveyed reported cloud computing as their highest IT priority. 60%, which is why more and more of our incident response and forensic calls are involving the compromise of cloud systems. I don't know if anyone saw the panel discussion this morning, but one of the points that I did make was shop your cloud vendors, interview them, because in a lot of the incident response and forensic calls that we've done, a lot of the cloud companies would not give us a snapshot of the system. Right, you're probably shocked to hear that. It's actually, you got to find out if you're a multi-tenant, what kind of structure, all of those things, those all come into play. We've done, most of the incident response calls we've done have been live forensics, meaning that we had to SSH into the machine, RDP into the machine, upload our tools, and do the forensics. Raise your hand if that totally sucks. Yeah, it totally sucks. Because, first of all, there really isn't that many white papers on how to do forensics, live forensics. There really isn't much out there because you're expected to just kind of walk up to the bare metal, plug in your flash stick, and you're good. Live response, right? reboot it, or just do a live capture, grab everything in memory. The cloud complicates that, so we're going to talk about that today. As with most of terminology in InfoSec like DMZ, the word red teaming it comes from military use. So red teams are independent groups that challenge an organization's norms, right? So actually red teaming does not just apply to penetration testing. It does not just apply to information security. You can red team anything. Okay, you can red team and blue team anything. The US intelligence community uses red teams to explore alternative futures, writing papers and dissertations for alternative futures. It's really cool stuff. You can red team pretty much anything, not just an IP address. Broadly speaking, a red team challenges a company's norms, right? Red teams emulate an adversary or competitor as a surrogate, where the red team plays the opposing force. In the military, we call that OPFOR. Okay, for some of you military in the room. Happy Veterans Day, by the way. Thank you for your service. The objective of the surrogate adversary is to sharpen skills, expose vulnerabilities that adversaries might exploit, and in general, increase understanding. We just did a data breach a week ago, and I was sitting down with the CEO and legal counsel, CFO, CIO. They're all at the table. And we came right on the incident. Incident cost them so far in just professional services hours about 1.2 million. 1.2. We had Accenture project management. We had all these companies over. This was like a 4 or 5 month effort, right? Incident response on advanced persistent threat investigations, you guys. Typical time that we see adversaries on cloud servers or on systems on the network is 12 to 18 months before they're detected. 12 to 18 months. Imagine how long that cleanup effort is. The biotech company that I told you about that got popped by China, they're still doing the response. It was over a year ago. They're still on the network. Still having trouble getting them out. Okay, it's a real problem. So one of the things that we did at the end of the investigation is we told them, like, look, when was the last time you guys did a pen test? Oh, we didn't see a need for it because we know we have vulnerabilities. What? I need more coffee. What? So yeah, pen test. Find your vulnerabilities before your adversaries do. It's not about whether or not you know you have vulnerabilities. It's about finding the critical ones in the I don't care about the law. SSL naming convention, SSL name mismatch on SSL certificates, that's not pen testing. That's Qualys Guard. That's Nessus, okay? I'm talking about pen testing, like root your stuff, admin your stuff, get a root shell, and just steal your crap and leave with it, and then hand the CEO his email. That's pen testing, okay? I'm not talking about Nessus reports. Real pen testing, real red teaming. It's a lot of fun. We actually, in the middle of one pen test on the cloud, they actually had no servers in the network. Everything was in the cloud. Their CVS repository, GitHub, okay? Their servers, AWS. We ended up hacking through their VoIP phone system. Totally different PowerPoint, but anyway. My point is that everything's moving to the cloud. You need a red team, you need a blue team. Okay, let's talk about the PTES. Methodologies. 4 major steps. Go to pentest-standard.org. Great site. So some really smart people around the world got together and said, you know what, we have this problem where all these consultants are doing pen tests differently. We have this problem where everyone is just kind of calling a vulnerability scan. But raise your hand if you hired a pen test consultant and they came and did a pen test and then handed you a report with the Nessus logo on top and charged you 18 grand for it. Yeah, happens quite frequently. You could have went and bought Nessus for $1,500 and ran it yourself. Okay, that is not a pen test. Okay, so the pen test, so these people got together and said, let's create a standard. Let's standardize this stuff, man. Let's standardize. So start with recon, intelligence collection. A lot of the methodologies from penetration testing, if you think about it, line up very similarly to military operations. So intelligence gathering, what are you going after? Where are their weak spots? Okay, what are the high value targets? Identify the vulnerabilities, and then choose what are called your HVTs. What are you going after? A lot of companies are like, security onion, man, defense in depth. Start shooting rubber bands at me if you want, but I will put money on it. I'm telling you, defense in depth is dead. And I'll be like, wow, oh my God, I can't believe she just said that. I did. I believe defense in depth is dead because I think it was for a different adversary. Defense in depth was created at the time when 14-year-olds were picking their nose in their bedroom and defacing websites. We are dealing with a different adversary. Companies are being brought into the cyber battle space like countries. We are dealing not with website defacements, but the theft of intellectual property, data, and extremely large amounts of money. Extremely large amounts of money. Russia is the largest importer of stolen credit cards and identities in the world. Most of the data theft as it relates to credit card breaches and financial theft, usually we find stuff written in Russian. They're usually Russian crime syndicates. Okay, it is nation-state warfare. And these are companies that are being brought in. So I dare to say, when the military started to face ununiformed combatants, when they started to face civilian surges, they didn't go to Boeing and Lockheed and say, make us a new civilian bullet that kills civilians. We need a new high-tech bullet to deal with coin. Counterinsurgency bullets, can you make them? No, we wrote new manuals on how strategically to deal differently with our new adversary. We adapted, and I believe that that's what we need to do. Stop trying to build your security from the outside in because they're not coming through there. 90% of the incidents we responded to in 2014 came in through their VPN site-to-site tunnels. They came in through their supply chain who they had VPN tunnels with, but management did not come down from the 12th floor to let IT know that that relationship no longer existed, so the VPN tunnel stayed up. Raise your hand if you think senior leadership always communicates the termination of a supply chain relationship to network engineering. Okay. Pre-engagement interactions, then you move to vulnerability analysis, identify the vulnerabilities, decide the critical vulnerabilities you're going to exploit, and go after them. Pivot. This is a big thing. Pivoting. So once we gain a foothold on the network, we've identified the vulnerabilities, we've exploited it, then we start looking for your crown jewels. I believe that defense in depth is dead because I believe the new security program should start from securing what you know you're trying to protect. Most companies and the incident response cases that we've dealt with did not know that their data was no longer on the servers that they installed semantic DLP on. It had been copied to so many shared folders and NetApp servers. It was no longer on the servers that they had purchased all this expensive product for to protect. Companies no longer know where their data is, their crown jewels are. Build your security onion around your data first. The perimeter does not exist anymore. It extends to Starbucks. It extends to your suppliers. Cool, thank you. I was like, I want to know which car this chick has out there. I'm going to key it. What does she mean that defense in depth is dead? It was built and designed at a different time. God bless the folks at SANS Institute. I actually took the last class that Stephen Northcutt taught on GCIA. A lot of it was really coined out of SANS. Really smart people, great thing. I believe that defense in depth needs to be switched with something else, a new type of mentality and methodology. So post-exploitation, that's really just pillaging, identifying the crown jewels, going after it, and taking it, and leaving the network with it. Okay, so when we perform a pen test, this is really what we follow. All of the stuff in blue are your initial recon, then you move to the right, exploitation, post-exploitation, evidence collection, and reporting. The cloud. One understands the cloud. Okay, let's talk about the cloud. I know there's some really, really uber smart cloud people in here. I get that. I can point you out in the audience. I know who you are. And I know some of you don't know what the heck an elastic beanstalk even is, or even what the cloud is, right? So we're going to talk about it. A tenant is an individual organization that's contracting the instance or the service being provided. That's a tenant. Think of it like an apartment tenant, staying in an apartment, okay? Multi-tenant is a single instance serving multiple tenants. multiple people living in an apartment, right? All sharing the same instance, all sharing the same resource, multi-tenant environment. Can you see where this is leading when it comes to incident response, right? If you're in a multi-tenant environment, I'm about to show you a really cool quote. We'll get there. The provider is basically the one who builds and maintains the infrastructure and provides those resources or those instances to the tenant. It's typically sold hourly. You're like, what? Hourly? Yeah, I was like shocked by it. When I first saw it, I was like, what? Because I'm used to like Host Monster, like $19.95 a month, right? 500 gigs, $19.95 a month. Okay, totally different with the cloud. It's all usually hourly. But, and some of you are like, oh God, this girl doesn't know what she's talking about. There's reserved instances on Amazon. Yes, okay. You can buy a reserved instance, okay? And actually, when you buy a reserved instance, you basically pay for the whole year in advance. And so you're getting that kind of flat fee kind of model. And actually, when you're done with the reserved instance, I actually just found out this recently, there's actually auctions where people are like auctioning off their reserved instances when they're done with it. It's totally crazy. Anyway, so that's a tenant, multi-tenant provider. So in order to talk about hacking the cloud, I need to first introduce you guys to the concepts of the cloud. Okay. Private cloud is typically deployed on a local LAN. Provider and tenant are part of the same organization and operate behind the firewall. It's private, secure. I hate using that S word. It's behind the firewall, let's call it that, okay? Public cloud, service provider makes resources available to the general public over the internet, typically offered as a pay-per-usage model. This is usually the most typical kind of model. Federated cloud and hybrid cloud, actually Tom Caldwell and I, good friend, partner, client. Tom and I were having a great conversation about how a lot of people just kind of interchange that term federated cloud and hybrid cloud, because if you read the definitions, they're very similar in many sense of the word. Basically, okay, so company has public cloud and they have a private cloud. They put some of their non-critical, non-PII, non-payment card data in the public cloud, and then they put their like really uber secret, top secret, classified stuff, hybrid cloud, okay? So those are the different type of cloud models. So what's really cool is you also have these different types of services. Platform as a service, tenant supplies the application to deploy and provider supplies the necessary resources to run it. Example, Microsoft Azure. Or Azure, I can never get that. Azure, okay. Cloud Foundry, software as a service or SaaS, Salesforce, right? Here's your application. Don't worry about building Apache or Windows IIS. I'm waiting to like get this guy. This guy's like so serious looking at him. I'm like waiting to get him to laugh. I'm like, oh my God, it's a Fed. It's a Fed, I can tell. No, now he's laughing. Look at that, he's really red. He's really red. Okay, all right, I'll leave you alone. Okay, so Salesforce, don't worry about the hardware. There was a talk this morning, it was like, I worry about the jobs of the IT people. Like the IT people, I feel like, do you remember when you're like, all right, let's go download Slackware, download Apache, get like Apache mod, compile it, get the website up. Those days are gone. Those days are gone. But we've entered a new age. And I dare to say that the job of the IT person is really not dead. And we'll talk about that in a minute. So the provider basically supplies the application all resources to run it, no software. You know that, you guys are familiar with that no software sign from Salesforce? Basically the same thing. Infrastructure as a service, this is Rackspace, AWS. Most of you here probably run your servers in AWS. Okay, a lot of really cool security stuff. Maybe some of you use Azure. Basically, they provide and are responsible for the everything below the virtual machine, right? You're responsible for the virtual machine and up, depending on what kind of instance you have. We'll talk about that in a minute. IaaS, because I'm so gangster, I'm gonna call it IaaS, okay? So IaaS, PaaS, and SaaS, okay? So everything from the red line and up is the responsibility of the tenant. Everything from the hypervisor down is the responsibility of the provider, depending on the type of cloud platform. Now, some of you are probably totally hackers, and you're probably already thinking about this, especially you like right there in the carpet, you're like totally elite hacker, that girl right there. But she's like, it's always the most innocent looking. Actually, the most elite hacker I ever met was a girl, I kid you not, it was me, that's okay. Okay, so provider is hypervisor down on IaaS. So if you think about it, we can start applying these concepts, you can start looking at some of the holes. Okay, elastic beanstalk, all right. Elastic Beanstalk is basically Amazon's thingamadookie, where you can basically auto-scale systems, automatic provisioning and scaling of infrastructure using auto-scaling, automatic installation and management of application stack, deploys, manages, and scales web apps and services for you. I'm about to talk about a case study that from a real-life incident that we had. I want to first talk about the fact that, think about auto-scaling for a minute. All of you IT folks, all of you people, even if you're not IT, think about it. If your cloud is automatically destroying servers and building servers on the fly every couple hours, how do you pen test that, right? If your IP address is automatically and dynamically being reassigned between systems, or let's say you have a compromised box. Let's say someone popped one of your servers, one of your web app servers in AWS, and one of your servers is torn down and rebuilt, and that server is the one that got popped. How do you do forensics on that? Really great conversation this morning in the panel. I wish you guys would have been there. I think it was recorded, so you will be able to download it, but it was a great conversation about this. Okay, so we're going to talk about an actual case study where that actually happened. Let's talk about the cloud stack. So you're probably like, hypervisor, that's kind of cool. Sounds like a new F-18 Hornet, Navy cool thingy with big missiles. Hypervisors basically creates a virtual version of each hardware component, allocates it to each virtual machine, manages virtual resources for the virtual machine. It's VMware. It's VirtualBox. It's all, your hypervisor is basically takes your physical RAM. Okay, step back. Gen 1 computers, right? I'll call them Gen 1 computers. Gen 1 computers, you got your motherboard, your CPU, your RAM, your hard drive, and then you installed Windows or DOS. Okay, whatever. Okay, you have your operating system. Okay, then you put your hypervisor on your computer. Now your hypervisor basically recreates that and basically creates virtual versions of the RAM, virtual versions of the CPU, and basically manages allocation of the RAM and the CPU and the hard drive space, each virtual machine, and it allows you to actually start these virtual fake computers inside one physical computer, and with bridge networking actually appears as a physical computer on the network, and you can ping it, and you can SSH to it, and you can RDP to it, and it looks like a real machine, but it's a virtual machine. It's virtual. Now, let's talk about that for a minute, because as a hacker, you always think, you're like, okay, how do we break things, right? When I was little, I was like, I knew I was a hacker. I started hacking when I was 13, right? I had no social life as a child. But as a child, I was like thinking, how could I undo this or break this, right? What can be made by humans can be broken by humans, okay? Let's talk about that for a minute. Someone see something wrong with this? What's wrong with that? Do you see the first-gen computers and then the second-gen computers with the virtual machines and the virtual RAM, the virtual CPUs and stuff? Yeah, you got multiple attack points. Your attack surface has now increased. How come no one's talked about that, right? I've sat in through almost every lecture today, every presentation today, and I haven't heard, no, that's not really true. But I've sat in a couple, and no one's really talked about that. When you're deploying into the cloud, you're actually increasing your attack surface. Now, look at those virtual devices in this box right here. Look at that. In order for the hypervisor to recreate these as virtual things, virtual devices in those virtual systems, it's like a hook from the host OS into the guest OS. It's like a hook. Sorry, right? It's a hook. Like, here's your RAM, here's your CPU, and it's like a bridge between the hypervisor and the virtual machine. I wonder if that can be exploited, right? Okay, what are you going to do today, Pinky? We're going to take over the world, brain. Okay, so we were doing an incident response case, and I kind of already ruined it, but we're doing this incident response case. It was a credit card breach, and the cloud provider that the company chose, they're actually based in LA, I won't say the name, but the cloud provider that they chose, in the middle of the incident response, we had the Secret Service. It was a lot of credit cards. It was actually in the news. Anyway, we were working this incident, and the cloud provider, even with the Secret Service working with us on the case, would not provide us the snapshot of the compromised machine. We even asked if they could fire up another instance for us to actually, raise your hand if you think you can DD a hard drive, a bit level forensic image of a hard drive to itself. Raise your hand if you think you can actually DD a hard drive to itself, a bit level copy of the hard drive to itself. No, I mean, you maybe if you like hack DD or something and like you can't image a hard drive and then write back onto itself. You can't do that. You fire up, if you have to, you fire up another instance and you DD to that. You DD to that other image. You have a forensically sound copy of that image. They wouldn't fire up the second instance for us to DD to because they felt it added some legal liability to the company if they did that. So please, 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 please. This company paid a lot of money in this incident response case, and a lot of it was spent on man time working with the cloud provider because they wouldn't work with us. It's really sad. We had to do live forensics on that machine. It sucks. It sucks. And it takes so much more time. So interview your cloud providers. Okay. Cloud pen testing. What you really came here for. All right. Chris Brenton came with this awesome quote. I actually got to give him props because a lot of this was Chris. Arguably, one of the biggest disruptions that cloud computing has introduced to red teams is the concept of shared ownership. How do you pen test an environment that multiple companies own? How do you do forensics on an environment that multiple companies own? Cloud introduced shared ownership of infrastructure and systems, and it complicated things for red teams. That's what this talk is about. And even more importantly, not just breaking out of the guest OSs, which is possible, and we'll talk about that in a minute, but also forensics. So I'm going to be doing another talk on forensics in the cloud, which is a really cool talk. But the concept of shared ownership is huge. All right, let's talk about this for a minute. PTES plus cloud. So if you apply the PTES to this actual architecture, you have to ask yourself, what layer is in scope for testing? Any pen testers in the room? Ooh, yeah, okay. So, oh, good. Okay, so take the PTES and think about cloud models and cloud service architecture. It's driven by the deployment model and it's driven by the service model. Do you guys remember that chart where I said everything down was the provider, everything up was the tenant? You got to take that into consideration along with your pen testing because you can't be testing the hypervisor on a SaaS provider. Bad idea. Salesforce doesn't really like that. Okay. Is the target a provider or a tenant or both? It is possible to be both. We talked about that, right? So it is. We have been engaged by providers. It is possible. They will actually ask you to test pretty much almost the entire stack. It depends on who your client is or who you are as a company. And it's funny. We've actually been on several engagements where the client doesn't know. Yeah. We were on pen tests where the client didn't know what kind it was. Was it a SaaS? Was it a PaaS? Was it? And it's really important for you as pen testers, especially when you're talking about legal liability and getting permission to test forms. A lot of people, I school a lot of pen testers that just don't do permission to test forms. Bad idea, especially in the cloud. Most of the times your client will either lie or they won't know. Usually it's both. So basically, is it a public or private cloud assessment? Is it IaaS, SaaS, PaaS? A tenant within an IaaS deployment is responsible for the VM and everything within it. So if you're contracted by a tenant, those and all loaded applications are fair game, provided third-party pen testing is acceptable. Please, please, please. I've seen 2 pen testers now get arrested for that. Seriously, I'm not kidding. 2 pen testers were arrested for doing a pen test. They didn't know they were hitting third-party equipment because the client didn't tell them. Ask the questions. Do you guys ever remember that? Did anyone ever watch House? I was like addicted to House, right? Do you remember what House used to say is like, don't ever talk to the patients because they just totally lie to you. It's like the same thing for pen testers. If the client doesn't know, they're straight out lying to us. They've got deadlines, man. Like they got to get that pen test in because they put it off until the end of the year for their PCI requirement. Got to get it done before December 3rd. Oh, by the way, I'm going on vacation for Thanksgiving tomorrow, but good luck with your pen test. And don't worry, we're an IaaS, right? Don't worry about it. All right, so it happens. Be careful, man. Be careful. Your clients are lying to you. All right, Let's talk about the weaknesses in IS. That's why you're here, right? All right, patch management. Operating systems are provided without patches. I think security should be totally wrapped in with it. Like, it shouldn't be totally hard. So I totally agree. I've seen many cloud service providers like, here's your Ubuntu instance. It's yours. But in the terms of service, the client didn't know that they were supposed to secure and patch it. A lot of people just don't know. There's no pop-up window. Patch your dude. Yeah, sorry. No kids in here, right? Sorry. All right, we're all over 18? Yeah. Okay. So there's no disclaimer. A lot of admins don't know that they're supposed to patch their stuff. Oh, my favorite, 86,000 credit cards stolen on this one breach. And the guy, the COO of the company actually came back to me like, I don't understand how this can happen. Like, what do you mean? What do you mean? The cloud provider was patching us. They were running pen testing on us. Be really careful for you pen testers out there. Have you ever heard of a cloud service provider doing pen testing as part of your service? No, it's scanning. It's vulnerability scanning. Totally different. Totally different. Microsoft disabled automatic patch updates requiring administrators to log and run it manually for servers in Azure. That's the Microsoft guy right there. No, just kidding. So actually Microsoft doesn't turn patching on by default, right? You have to actually log in as administrator and manually initiate the patches. Did you guys know that? I know, not many people know that. It's really frightening actually. I don't understand that. If someone who contracts Azure or knows someone at Microsoft that could tell me why, I've not found out. A lot of the incident response cases we dealt with were because Windows wasn't being patched. You know?
So I've heard the explanation is just like in your IT environment, right? You don't just blindly patch things. They typically go through some testing. So
right, and do like SCCM or something like that, and push patches out manually.
You just don't push patches without testing in your
right.
production environment, and so they're thinking the same thing. Well, we can push patches, but we can break things, and we'd have a whole other issue to deal with.
Right, and
That's
then.
what I heard. I don't know how valid that is, but
Yeah, and a lot of people think like, oh man, it's this magical cloud, right? We don't have to it's not part of our on-premise, our on-prem stuff. It's like, how do we add those? Like, how do we do we patch? I thought Microsoft's taking care of that. It's just I think it's a lot of assumptions with the provider. I think that's what's happening to us. We're assuming a lot with our providers, and we just can't do that. We can't assume, right? Okay. IS uses a gold standard image that is replicated with every new build, replicating vulnerabilities across servers. Seen this happen a lot, right? So you have these gold standard images where you've got these servers being built from. So you have these like chef recipes where they're these enterprise build images. And so if you have a vulnerability in your gold standard image, every new machine that gets spun up and shut down and spun up is going to contain that same vulnerability. So it's another weakness in IS, right? Just keep it in consideration. Network security. Most IS providers offer little to no firewall services, e.g. Did you know that in the Amazon EC2 basic services, did you know that you actually, your security group is actually only applied when the server is booted? So people actually will go in there and make changes to the security group, and they didn't know that you actually have to reboot it in order to grab that security group. And a lot of people don't know that, right? So they'll keep their cloud servers running, they'll make these changes, they think, like, shell shock, anyone remember shell shock, right? Anyone involved in those patching? So shell shock, great example. So a lot of times they'll think they closed a firewall port or they closed something off, and they didn't know they were supposed to reboot their machine. Attacking the hypervisor. No, that's not possible. It is possible. It is possible. And actually, we just did a pen test recently, and I'll just for giggles, I'll just tell you right now. They were these Dell hypervisor appliances. I forgot what they're called, but Dell makes these like dedicated hypervisor things. And we're like, oh my God, we run those. Somebody rolled all these things out without changing the default password. Humans are the weakest link in security. I'm telling you, humans are the weakest link in security. It's the way it goes. It's what it is. We're the weakest link. Okay, so it doesn't matter how strong your security is, how great your encryption is. You roll something out with default password, you're done. Right? And what happens if you have access to that hypervisor? everything running inside of it. Okay. This is a big one, right? This is like, oh, this is it. This is the moment. Introspection, right? Raise your hand if you know what introspection is. Ooh, okay. This is going to be fun. So there's a technology called introspection. What introspection does is it allows your hypervisor, the hypervisor is able to actually get into the hard drive of the virtual machine and pull stuff out. And get into your guest OS and pull out memory. Oh, feature. That's what hackers do, right? We don't attack holes or go after, we exploit features, okay? So if you compromise that hypervisor and you compromise that introspection, you can we've actually been able to carve files out of the guest OS, and get this, here's the best part. The guest OS doesn't do any audit logging on it because it doesn't actually see it. It's all virtual. It's a virtual hard drive, dude.
That's how single instance memory storage works in VMware.
Thanks, and guess who I'm talking about right now? The big V word. I've got stock in them, so I'm not going to say the word. Okay, so introspection, go read about it. There's some really cool stuff on it. Okay, default passwords. All right, determining the target IP information in an IS penetration test is difficult. A cloud is shared space, so you cannot count on a tenant's IP address range to be continuous. Okay, so it happens all the time. You guys got to understand, as you know, in cloud, things move around, they shift around, they move with the ebb and flow, and they relocate virtual machines. Things get moved around. There's customers in the middle of IP space that's supposed to be continuous. You got a block of like a cider block of like 8 IPs here, and it's Acme or McDonald's, and then Wendy's is over here. Just be cognizant of that. It's really important, okay? The allocated IP addresses change as servers are frequently brought up and down. Happens all the time. Very possible, very possible. Happens on almost every engagement. The IP that you think you're attacking, for you pen testers out there, can actually change to a different machine in the middle of your pen test. Happens all the time. You guys want to talk about changes to pen testing? Am I running over? I'm running over. I'm bad at that. Okay, virtual machines. Okay, so memory corruption bugs in virtual machines, that go look at all the exploits out there, because they do exist. The exploits for virtual machines, for guest operating systems, all come down to memory corruption bugs, which actually allows you to write the buffer space right into the hypervisor. The virtual device drivers. Okay, so in a particular virtual machine, which shall remain nameless, there is a memory corruption bug. Okay, there's a bug in the SVGA driver. The device driver, the virtual SVGA card, has a bug in it. Can you imagine your SVGA card, your video card, having a bug in it? Well, you can actually ride this bug right into the hypervisor from your guest OS, allowing you to what's called break out of your guest. Guess what I've got? Links! Okay, so in 2008, adventures with a certain key Zen vulnerability, a group calling themselves Invisible Things Lab, integer overflow and the paravirtual frame buffer. Paravirtual frame buffer, go check it out. Awesome write-up. This is how far back vulnerabilities go. Cloudburst from immunity for VMware, missing bounds checking in the virtual SVGA device. Again, get memory corruption. Memory corruption. Do you guys recognize this? Can anyone say buffer overflow? Heap overflow? Stack overflow? All that stuff that we remember from the olden days. I'm a lot older than I actually look, I promise. So all that stuff that worked before works in hypervisors, in virtual machines, to break out of the guest. There's software attacks against Intel VT-D technology. Again, Invisible Things Labs. Bug in the way Zen uses Intel's I/O, MMU, and hardware I/O protection technology. Bug in the way interrupts were handled that allows a guest to escape. Again, memory corruption. For those of you who are interested in writing your own buffer overflows and exploits, check out memory corruption issues with your guests. All they are is just software. Stop thinking that they're this magical blue unicorn thing that's like, oh, this is God's gift to security. It's like a hack. No, it's just an application, guys. It's a software. It's software. It's software. What works against your IIS web server? Same kind of stuff, dude. Same kind of stuff. Okay, lessons learned. I actually wanted to do a demonstration where I actually break out of a guest OS, but I wasn't able to actually do it. The conference wasn't allowing it. So I actually spoke at Black Hat briefings. If you guys are interested, come see me. I do this kind of stuff all the time. Really great write-ups. Come grab me from my website and email later if you want. Choose your cloud provider carefully. Interview them. Ask them what access you have if the machine's compromised. Guys, this is 2014. You're going to get hacked. It's not about if or it's about when. So ask your cloud provider when that happens, when the proverbial oomph hits the fan, what are you going to do for me? What is their policy on penetration testing? Ask. Find out what their policy is for third-party pen testing your VM stack application. Penetration testers, time your tests well in advance. Amazon takes some time to get back to you. Sometimes they don't even get back to you. Okay? If you go to aws.amazon.com/security/penetration testing, you can get their information. This is a big one. Did you guys know this? You cannot actually pen test the small and micro devices instances. You can't pen test them. So you cannot pen test the M1 small and T1 micro instances. It's not allowed. Amazon will not let you do that. Did you guys know that? A lot of people are like, what? No. There are certain instance types that if your server is on it, and this, I think these are like their least expensive instances, but a lot of people use them for like web apps or whatever, like low footprint stuff. You can't pen test those. Amazon will not allow it. So find out what instance types you guys are running, find out what your company relies on, and make sure that it's in line with your expectations. So, summary, proper scoping is even more essential in performing cloud pen testing. Stop jumping directly to the command line. Stop jumping to bash and starting to /Kali Linux. Just scope it. Please, scope it. Talk more with your clients. Who is the client? Are they a provider? Are they a tenant? What's the cloud model? Is it private, public, or hybrid? What is the server model? Is it IaaS, SaaS, or PaaS? That determines targeting. What are you going to actually go after? Think like a hacker, because I sure as hell promise you that's what they're doing. They're thinking like hackers when they break in. Okay? Get your permission to test form, especially for tenants, please. Hypervisors are just as vulnerable as any other application, but give you pivoting access to all the internal hosts that it's running. So if you hack into hypervisor, I'll tell you one thing. When I go in on a pen test, first thing I'm doing is looking for hypervisors. You actually have an application. There's a way to actually find the hypervisors on the network. You guys know that? Actually can scan entire network blocks looking for hypervisors. It's possible. Attacking VMs are vulnerable to the usual suspects. Virtual devices are a weak spot as well as memory corruption bugs. Go after the virtual devices in the actual guest host. If you do an ifconfig and you find out and you see a bunch of VMnet stuff, VMnet, you guys recognize that? Virtual machine network interface cards? You're in a virtual machine, okay? Go after the virtual devices because it's your slope right into the actual hypervisor. Remember, clouds are shared hosting environments. And I just wanted to thank a few people, Chris Breton again. There's some great write-ups. If you guys go check out the SANS Cloud Security blog, great blog on cloud security and cloud pen testing. And that's it. Thank you. So, that was like the longest clap I ever got. So, any questions? Yes?
How do you protect the hypervisor?
Ooh, good question. Good question. I guess if you think about it, you have to ask your same question about how do you protect your servers and how do you protect your critical systems. You definitely want to make sure. One of the biggest problems that we found in our testing is that a lot of the networks are flat. Okay, raise your hand if you actually think that network architecture is a requirement of PCI. Ooh, very good. I've had a lot of people raise their hands on that question. Network architecture is not a requirement of PCI. Look at Target, look at Home Depot. You guys see those? Did you guys read the details on those? Flat networks. Hypervisors and most of our tests were on flat networks. Same networks as your
PCI
workstation.
version 3 tells you to segment your CDE environment, but only that small piece.
Right, it doesn't talk about your overall. And the problem is and if you think about it, most of the, it's really weird, I'll be on a pen test and the company will have multiple VLANs, but there won't be any VACLs. There won't be any VLAN access control lists. It's like you have VLANs, like, why do you have VLANs then? So we can have different CIDR blocks. Well, there's no security around it. You don't have your servers in one VLAN, or if you do, there's no ACLs, there's nothing. So most of the time it's like, move your hypervisors to your server VLAN, protect that server VLAN, govern your access into the hypervisors, role-based access control. It's all the same stuff. And a lot of people are looking like, Alissa, give me this white paper, give me this link to this like uber top secret classified document on how to, it's not, it's the same stuff we've been doing for years, but we just got to apply it differently, right? Back to the analogy, military didn't go out and buy different, better bullets to go after counterinsurgency, right? We just adapted and changed. We need to do the same thing.
Have you seen any malware attacks targeting hypervisors, like malware specifically related to target hypervisors?
Am I aware of any malware that targets it? I'm aware of exploits that target hypervisors, but malware, once you've got an exploit, then you've got malware. It's really easy to turn shell shock into a worm. They're waiting for shell shock to be turned into a worm. I haven't seen anything, but you start at point A with the actual exploit, and you move to malware from there.
From a pen tester perspective, what are some ways a pen tester would maintain persistence on instances that are being destroyed and brought back up?
Ooh, that's a good one. So you can actually write your own chef recipe if you can get access to the systems that are actually governing control to the chef recipes, or it depends on how deep you actually penetrate. But basically, if you think about it, it's all being rebuilt on an image. So if you can inject your malware into that base gold image, create a chef recipe or whatever it is, modify that actual gold standard or that EBI, then every time a new machine is rebuilt, it's gonna rebuild it with that backdoor. So it depends on how. I've never gotten that deep into a pen test, especially with AWS. But again, theoretical, right? So your hypervisor, if you think about it, you've got two types of hypervisors. You have a bare metal hypervisor, which means that there's no operating system, and then you have a hypervisor that's installed on top of an OS. There's less performance and less system resources for the guest machines, but you're right. If you can actually compromise, and we have done this in pen tests, because if you think about it, the hypervisor is only as secure as the operating system that it's running on if it's hosted. So if you can compromise the Windows machine running VMware ESX or whatever it is, then you've got persistence to the hypervisor, giving you access to the rest of the virtual machine guests, and it happens all the time.
What's
Yes?
your experience with SaaS providers allowing third-party pen testing?
There's a couple that will not allow it. It just, it's that whole legal compliance thing where the lawyers are like, no, this is not going to happen. You got multi-tenancy. You got. I can tell you, AWS allows it. Amazon, of course, allows it. You just have to fill out a permission and test form. There's a couple of the names that escape me right now. They allow it, but I mean, it's you got to ask your provider. Remember, cloud in the Microsoft dude talked about this. They know that it's really easy for you to pick up your stuff and move to the next cloud provider if you're not happy with them. So they're focused on customer retention. Call up your account manager, call them up or her up and say, dude, can I pen test my stuff? If they say no, thank you, have a nice day.
I'm talking about IaaS, I'm talking about SaaS.
Oh, SaaS, ooh. So no, I guess, yeah, same reason, multi-tenancy. You've got other customers' data on it. I have never seen it. There was one instance where we did a pen test where they actually did make a copy of the virtual machine, basically replicated it, and we did a pen test on that. But again, you're talking about, buying someone lunch as a favor for that. It's really tough to do. It's really tough to do.
See any cloud provider, any breaches on a cloud provider where they move from one tenant to another?
Yes, we have. This was about a month and a half ago. It's very common. A lot of our investigations involve cloud providers. It is, when you're talking about the nation state threats where they're using zero-day stuff, they're using stuff that you guys haven't even heard about. A very small percentage of the exploits actually make it to dark reading, just understand that. And they will pivot, they love to pivot. Because once you have access in, once you've got a remote in, Then they spend months learning the network, and they figure out how to pivot. Very possible, yeah. It happens all the time. Happens all the time. Any other questions? Thank you so much. Thank you.